Hello to all you current Crusaders out there, and welcome to Tesla Harmonics, where today we're going to try to begin to unravel the mysteries of electrical motor control diagrams. I'm Eric, and today we're going to dive right into the world of ladder diagrams, a visual language used in automation. Before we begin, I wanted to address a question of what are some of the common symbols that are used, how do I learn to read symbols, how do I learn to read prints. So what we're going to do today is that we're going to look over all the symbols that we'll use just in these programs that we have for today. The good thing about these symbols and the ones that I picked, I think if we can understand them and get a good foundation with those, we should be able to translate the knowledge from them right over to all the other different switches and contactors and things that have come along. All right, so let's get right into it. We're going to go over those symbols. Let's do that right now. Okay, everyone, let's look at the symbols we'll be using today. First thing we got up here is an E-stop or an emergency stop. An emergency stop is put in line with power coming into a device. If I hit the E-stop, it stays where I left it. That makes it a definite state device. Like right here in these, we also have definite state devices. These two switches are like a light switch in your house, and they're on or they're off. And I use these two right here to show the two positions the switch could be in at either time. So with these, this one, you click it, just like you walk in a room, you turn the switch on, and the light comes on. That circle was connected to that circle. This is the power for that light going to it. And they put power on one side of the switch, and when the switch is closed or made, power goes out the other side. So a simple way to look at it is, if something is on or off, is the two circles touching or not? Well, this one right here would be on, and this one would be off. And if I click this one, it goes to on, and if I click this one, it goes to off. Same thing with the emergency stop. It would let the power go through, or if someone acted upon it, it would break it from the two circles, not letting power go through. We'll remember that these are definite state devices because they stay where we leave them. Then the next thing that we'll have is a normally open push button and a normally closed push button. And if I look at them, the differences between them, I say it's normally open. Well, I say this switch is open and this switch is closed. Why? This one is not touching the two circles, and this one is touching the two circles. That means in this one's normal state, without you touching it, it is normally off. It's not touching the two circles. And if I push it, it goes down and makes momentary contact. What's that? So I go down, it touches the circles, and it comes right back off. It's got a spring that pushes it back open. It goes back to a normal state. Where these have definite states, these switches have normal states. And normally it is up and not touching the two circles, so it's off and it's not pushing power. When you push it, it will momentarily touch them and then come back off. So if I wanted the light to stay on instead of making the momentary contact, I'd have to hold that button. Down here we have a normally closed button, and it is in its normal position without anyone touching it. It is connected this circle to this circle. So that means it is passing power. If I use this for the light switch, the light would be on right now, and I'd have to act upon this switch and it would momentarily go off, because this is a momentary contact switch also, but I'm momentarily breaking contact with it. And when I let go of it, a little spring pushes it back up, makes it touch the two circles. All right. Then we come along and we have a normally open contact and a normally closed contact. So contacts are like kind of like these switches over here, but they have the normal states like the push buttons. This one is normally not touching across from the left side to the right side, so it's open. It's normally off. This one is touching from the left side to the right side, so it's normally closed, and normally it's on if it's being used to pass power to a light. With the contacts, we don't actuate them with our hands. We use something that they're connected to. So they're going to be attached to a device that when that device energizes, it's going to be able to open and close these contacts. In the ladder diagrams that we're going to see in this video, we'll have a control relay, and on that control relay it has a normally open and a normally closed contact that we're going to use to control some lights. And then we'll have a red, yellow, green indicator lights throughout the circuits to just indicate things are coming on. I think we might have a heater at the end of it. It's just outputs. These are the things that are going to burn power that's over here. All right. Now that we've went over the symbols that we'll be using today, let's jump into the first diagram. A common question that arises is, how does a switch control a light in a ladder diagram? Well, simply put, when the switch is closed, the circuit completes and the light turns on. It's a fundamental concept, much like flipping a switch at your home to illuminate a room. Okay, looking at our drawing, I have a few circuits here, and I want to ask you one question building upon that concept and answering that question. What does a light need to burn? What does the light need to come on? Well, if you said a hot and a neutral, you'd be absolutely right. That's all that a light needs. So in this program, I can put power points anywhere that I want to. And I put me in a line 1 and neutral power point. So I've got 120 volts for lights and the control and other stuff. And I can turn things on and off. And if I take this yellow light and I put a hot on it and I put a neutral on it and everything's wired right, if I turn on power, that light illuminates. That is a very foundational concept that you need to start building upon to understand all the control stuff. If you don't know much about it, you may be an expert in this stuff and watching it. But if you're learning and starting out, this is a very foundational fact right here. What does a light bulb need to burn? A hot and a neutral. I ask people that are working with me in control classes all the time that question, and it'll start to click later on. You'll see. All right. So a light bulb needs a hot and a neutral to burn. Now, when we wire up things, we wire up loads, we wire up light bulbs, or whatever. Most people in class or other places, even if they don't understand electricity, they can say we need a battery, we need some wires, we need a light bulb. We kind of understand the circuit. So we can build a circuit, and then if we build upon it and start controlling a circuit, like maybe giving it switches and things to operate it with, now we can take the light and we can control it. We can turn it on and off. Now, very, very important foundational facts right here also. In this program, it's showing us that the hot side is red and that the neutral side is aqua colored. All right, so we can differentiate between the two of them that's there. And it's very important that we know what they are and that we keep them separate. With the light, knowing that all it needs to burn is a hot and a neutral, then we're going to control it with a switch. Then another foundational fact that we want to build upon for all of our control stuff is that we're going to switch, circuit breakers, fuses, switches, circuit breakers, fuses, and the hots only. Where does the switch, circuit breaker, or fuse go? In the hot or the hot only? The problem is if we put switches in the neutral side, the problem with that is that everything looks like it works normal. But this can cause a very dangerous situation that we'll talk about later. All right? So we want to make sure that we know a light bulb needs a hot and a neutral to burn, that we're going to control the hot side of the circuit, always leave the neutral just going directly to the loads that they're connected to. Now we're going to switch the hot side. We use a circuit breaker, it's going to be on the hot side. If we use a fuse, it's going to be on the hot side always. We never put any of those things in the neutral. All right, building out from there, coming down and looking at my next little circuit that I've started to set up like a ladder diagram. I put in another power point where I could get 120 volts. In real life, this may be a transformer. It might come off a circuit breaker, wherever you get your 120 volt control for, or 24 volt control, or whatever level of voltage that you're using. Really doesn't matter what the level of voltage is, it works the exact same way. All right, coming down to the next line right here, I have a line 1 that's feeding into a fuse, a circuit breaker, and a switch. I have all of that in the hot side of the circuit. That's what I'm protecting and controlling here. This white light over here has its neutral, and it's waiting to receive its hot. And if all those things are in good shape and I provide a hot and a neutral, that light bulb burns. Just like the first one that we put in, that just with the power source burn, then with the switch burn. Now when we come down here with the fuse and circuit breakers, completing the path, and we have the light bulbs on. When we went over our symbols, we also talked about normally closed and normally open push buttons. Further down the circuit here, I provided a power for this circuit and this circuit. And when we energized it, we noticed that this light came on and this light is not on. Well, this light is in the circuit with the normally open push button that we looked at earlier. And for that light to come on, I have to push that button. But since it's a momentary contact switch and the spring pushes it off, if I let go of the button, the light goes off. Now to keep that light running, I have to hold that button. All right? That is a normally open push button and how it's going to operate. When we come down one more line down here, we have the normally closed push button that we looked at. Power is feeding right through it. Why? Because power is coming to one circle. It's taking it over to the other circle because the button is normally closed, pushed up with the spring, and power is going right out that side straight to the load. It has this neutral and the light is on. Any of these lights could be contactors, relays, other lights, anything that we're wanting to power up and come on, that would be that way. All right. To make this light go off, I have to push that button, but it only goes off momentarily because it's a momentary contact switch. Here I'm momentarily breaking contact. Here I'm momentarily making contact. And when this switch right here, this is a definite state switch. This means that it stays where I leave it. Just as we said before. When I click it and leave it on, it stays on. When I click it and leave off, it stays off. Okay, everyone, that was it for that session. In the next session, we'll pick back up on the control relay and the much larger circuit that we talked about, and I will see you over there.